Welcome back and welcome to electrochemistry, where we're looking at chemical reactions and how electrons and charge move around when they're happening. The new things we're talking about here are oxidation and reduction reactions, and what those are is reactions where you're gaining electrons or reactions where you're losing electrons. And we have a couple of ways to remember those. We're going to talk about Leo Says-Gur and oil rig in a moment, but what we want you to get used to right now is when you have a chemical reaction, in addition to balancing all the atoms in it, which you've been doing for a while, the charge in a chemical reaction has to be the same before and after. So in this reaction A, it is not okay that we have +2 charge on the left and +3 charge on the right. That can't just happen. We need to have equal amounts on each side. And the way we fix this typically is we can add electrons to either side of a reaction. Now, electrons are negatively charged, so what you do with electrons is you add them to the higher charged side to drag it down. If we do this, now we have +2 charge on the left, and on the right we have +3 charge from this, -1 charge from the electron, total of +2, and now this reaction is balanced. So if iron 2 turns into iron 3, it must be because there's an extra electron present on the right-hand side here. Where did this come from? The iron 2 must have given it up. So it released an electron, and in the process, because it got rid of that negative charge, now its total is higher. When this happens, we say that the iron 2 lost an electron. And one of our sayings for this is Leo Says-Gur, which stands for losing electrons is oxidation, gaining electrons is reduction. The other one we use, which says the same thing with a different mnemonic, is oil rig, which stands for oxidation is losing electrons, reduction is gaining electrons. So looking at this, we'd say the iron 2 lost an electron, therefore it was oxidized. Yet another way you can think of this is if your charge goes up, you've been oxidized. That's a Z. And if your charge or your oxidation state goes down, you have been reduced. So looking quickly at this, you could see from +2 to +3, the charge went up, therefore iron was oxidized. Let's see if we can do some more of these. Seeing this, we have a total of -4 charge on the left, -2 from each oxide ion, and there are 2 of them. 0 charge on the right, so this one only makes sense if we have 4 electrons there. Now it's -4 on the left, -4 on the right, and we have it balanced. Again, that's a loss of electrons, and so we would say this is also an oxidation. Sorry, I didn't write oxidation for the first one, but I think I said it a few times. So we'd say the oxide ions were oxidized, their charge went up. Here we have nitride ions, total of -6 charge on the left, 0 on the right, so this one balances. If we put 6 electrons there, oxidation again. -5 to -7. Here, -5 is the higher charged side in D. So for this one to work, we'd need 2 electrons on the left. X5- gains 2 more electrons, and that drags its charge down from -5 to even lower, -7. This is the first one we've seen that is a reduction. The charge went down. Tin 4 to tin 2, charge went down, that's a reduction. And if you were balancing it, you'd have to add 2 electrons on the left. So that we would call a reduction. Copper to copper 2, to balance that, you'd need 2 electrons over here, and that would be an oxidation. Again, why is it an oxidation? Either because the charge went up, or because copper lost electrons, there they are, and according to Leo, losing electrons is oxidation, or according to oil, oxidation is when you lose electrons. Yttrium 3- to yttrium-, Minus is the higher one here, so to balance this, we'd need 2 electrons on the left. The charge went up from -3 to -1, so this is an oxidation. And last one, bromine starts out with 0 charge, goes to total of -2 charge. So for that to happen, we'd need 2 electrons on the left. If you gain electrons like this, according to Gurr, that is a reduction. Or the other way you can see it's a reduction. The charge of bromine went from 0 down to -1 each. Going down is a negative. That means bromine got reduced. Easy enough.